Thrustmaster. What do we know about them? Hello everybody, I am Nick the Naval Architect. So today I'm going to be reacting to a corporate overview video from Thrustmaster of Texas. They are a company that makes thrusters, azimuthing thrusters, and many forms of propulsion. And this is just their general corporate overview talking about them. And I have left a link down below to the original video if you want to check that out without my commentary. Let me know if you want to see more reaction videos like this. Leave your comments down below. Suggest videos that you'd like to see me react and talk more about. So now let's get into the video.
For over 35 years, we've continued to lead the way for innovation in advanced marine propulsion.
So this is the first thing that I want to show you. What you're seeing here is output from a program called StarCCM. It's a piece of computational fluid dynamics software. It's used for detailed analysis of flow through objects. In this case, they're using it to analyze, looks like a water jet. So you have flow coming in from the left side of the graphic, going through those rotating fins there, and then transiting out through the stators on the right side of the graphic. This is really important if you're a propulsion company because there's no simple formulaic design for how to design a propeller, or in this case, a water jet. There's a lot of trial and error, and CFD has really become a game changer for that because it allows you to test a lot of variations much more cost effectively. This represents a pretty substantial investment from Thrustmaster. That's a $30,000 to $60,000 piece of software. It's definitely a major development tool for them, pretty much essential if you're going to be doing serious propulsion development these days.
We design, fabricate, paint, machine, assemble, and test at the largest thruster manufacturing facility in the world. We're a vertically integrated company ready to provide a solution to any commercial or government marine propulsion opportunity. We're your partners.
That thruster that you see going out the door on the right side of your screen, that's probably about $1 million right there.
Our Thrustmaster. Thrustmaster has a passion for delivering the highest quality products, and we achieve this by controlling each step of the process in-house at our 300,000 square foot state-of-the-art headquarters in Houston, Texas.
Did you hear that? Houston, Texas. That's a major advantage for them. There are several geographic centers for maritime activity here in the United States. Houston, Texas is probably the largest geographic center. You have offshore oil companies located in Houston, Texas. You also have a lot of maritime companies that then support offshore oil. The decisions and the money happen at Houston, Texas. And being located in Houston, Texas gives them a major advantage because they can very easily just drive down the road and have in-person interviews, form personal relationships with regulators, with manufacturing support staff, with clients that are going to be placing these large orders, and it gives them the ability to be very tightly integrated, not only within their own company, but within the maritime industry surrounding them.
It all begins with sales and design. Thrustmaster prides itself on the personal focus we give each customer through our knowledgeable sales and applications engineering, who work closely with our customers to ensure the best propulsion solution is selected for their project. Our products are designed by our in-house engineering team, consisting of PhD and MSc engineers with specialized experience in all facets of propulsion engineering.
Okay, so we just listed off PhD and MSc engineers. PhD and MSc engineers are very expensive. And so it's quite common that those are not going to be the people doing all of the engineering.
Our manufacturing plant houses every step in the production process.
Did you catch this? So what we're looking at here is a 3D printer that's creating the impeller for a water jet. Depending on what they're doing, that could be the part that they're going to use to create a mold and cast that as metal. More likely, they're probably using that for prototyping. So that's also a very nice thing because that's going to indicate that they're doing prototyping both digitally and physically. That could very well be taken off to be tested in a small model scale tank. So again, this is another example of showing that Thrustmaster is investing in the equipment and the knowledge to continue to develop their products. And since this is the second time that we have seen a water jet component, that really signals to me that a major focus for their development right now is in water jets.
From the receiving of raw materials to the shipping of finished products, and ISO 9001-2015 certified.
Big thing there. ISO 9001-2015 certified. So ISO 9001 is a standard of certification for quality control. Now, that system needs to be customized for every single company. Everybody has different problems, and so you need to find different ways of assessing your quality. ISO 9001 means that you've had an external party come in and review your quality control system and demonstrate that that system is adequate at capturing those errors and ensuring good, reliable quality. So this is another example of Thrustmaster committing to quality, that not only have they developed their own quality control system with extensive documentation, but they have also paid to have somebody else review that quality control system. So another investment on their part on quality.
Our fabrication shop contains CNC-controlled machines for cutting, bending, and rolling, and a highly trained team of fabricators certified by all major marine classification societies.
Did you hear that? Certified by major marine classification societies. They provide the review of companies like Thrustmaster to say that, yes, we've had another external review to say that you are demonstrating good quality. And it's not only the production quality, it's also the design capabilities as well. Having that sort of approval by a classification society is a major hurdle to get over, and it's a major asset to your advantage once you get it.
Corrosion protection is performed in our fully climate-controlled paint booth, capable of handling equipment up to 30 feet wide and 75 feet long, by a team of NACE-certified painters and inspectors.
So there was another certification that was mentioned, NACE. Paint is actually an overlooked but very critical feature of the maritime world. You got to remember, these propellers and these thrusters are going to be underwater their entire life, constantly subjected to marine growth, to corrosion from seawater. It's just about the worst environment you can imagine for metals. A large part of how we protect those metals is through the paint. So being able to reliably develop and apply high performance, very technical paints is a very important thing.
Machining is handled in our climate-controlled machine shop, equipped with CNC mills, lathes, and machining centers, big enough to handle the largest thruster components. Our highly trained team of programmers, machinists, and inspectors have the experience required to machine high-tolerance components.
So everything they just described there, mentioning CNC for all of their components and all of their machines, that's definitely something you would expect for a large manufacturer. It's going to be very hard for them to just snap, bang, whip out a whole new design, because they have a huge amount of digital development behind each one of these, which are then translated into these CNC capabilities. So every component on one of their thrusters, there's a digital file for it, and then instructions for these machines how to cut out and build that physical component from the digital file, which means that it's not very easy to suddenly change a whole design. They've got a lot of inertia and they're committed to their existing products.
All critical machine dimensions are verified on our Zeiss gantry coordinate measuring machine.
Critical dimensions verified, that's part of their quality control process.
Our climate-controlled assembly shop has vast natural lighting and is kept clean and well organized to facilitate efficient, high-quality work. Control panels, electrical cabinets, and interconnecting harnesses are built in-house. Assembly cells are grouped by process and arranged to reduce the movement of technicians and material. Smaller components are delivered to these cells on visually controlled material carts to prevent the risk of foreign objects being mistakenly left in an assembly.
Probably what they're really showing you is some of their internal pride of what they think really differentiates them is not just quality, but their ability to be efficient in production. And that's cool. That means that they're taking pride in their work. Absolutely like that.
In-process inspection is performed throughout the assembly process. Rigorous post-assembly testing and factory acceptance testing is performed on all of our thrusters to ensure proper performance prior to delivery. After your product has been delivered, our worldwide customer service team is ready to assist you with installation, commissioning, and servicing of your thruster.
Commissioning, installation, and servicing of your thruster. What are you going to get for capabilities after you've signed the contract and given them most of your money? That's probably one of the biggest things that differentiates these manufacturers. This is a very large thing. You don't just bolt it onto the bottom of your ship. So for example, commissioning and installation. This is going to be shipped to a shipyard where the shipyard is going to install it in your new built vessel. That shipyard is going to need to coordinate with Thrustmaster. They're going to need to know things like the weight. Chances are the thruster needs to have a custom foundation built into the ship's hull. This is going to be one of the largest forces on the ship, so the hull has to be specially reinforced to handle it. All of those numbers have to be provided to the shipyard in advance. So asking about that coordination, how it happens, that's definitely going to be an important factor. It's very often that you can have uncoordinated engineering that delays production just as much as getting parts. And servicing is the next question. After we've got it, after we have it installed and we're using it, if a part breaks, how easily can we get that replaced?
We maintain a wide range of spare parts inventory in our factory's 25,500 square foot climate-controlled warehouse, as well as our other domestic and international service centers.
Okay, these little red dots are very important. You have to remember that we're talking about massive components here. If I need to, say, replace a propeller blade, that is a large, massive bronze casting that probably weighs half a ton to a ton at least. You're not just going to throw that on an airplane. This isn't something that Amazon is going to ship to you somewhere around the world. So the logistics of how to move these large components really matters. And you heard them mention that Thrustmaster has a large warehouse located at Houston, Texas, but we can also see that they have other warehouses located throughout the world. What components are stored in those satellite offices is really going to become critical. And you'll notice that those offices are all very strategically located to avoid having to ship freight across the oceans. So one of my critical questions would be, do they have those large components, things that we would have to put on a ship and transport, which could take a month or more? Do they have those components located in their satellite offices? Because we don't want to have our ship stuck in harbor waiting to get a replacement part for over a month. That's a huge loss. And this is the type of support question that becomes critical when you're evaluating your vendors.
At Thrustmaster, we're more than just a manufacturer and designer of marine propulsion systems. We're your business partner. We're committed to delivering the highest quality products at fair prices through continuous manufacturing improvement and product innovation. We're your partner.
What you're seeing here is propulsion in a box. Everything from this stand, from the yellow man walk on up, but not actually including the yellow man walk. All of that, plus the propeller that you see sticking down, that is a self-contained propulsion unit. That is an engine, a hydraulic power unit, all going down to power this propeller right here, all as one product. So if you have, say, a barge that you need to quickly convert over to slow maneuvering capabilities, say you want to suddenly turn it into a construction barge and you need to just do a little bit of maneuvering, you don't really want to take that barge and refit it out in a shipyard to turn it into a whole ship. So you can just drop this thing, one or two of these units, onto the barge, weld them down to the deck, install some rudimentary control systems, and now you have basic maneuvering. It's a beautiful solution when you need quick and dirty propulsion.
We're committed to quality. We stand behind our products. We are Thrustmaster.
And that is Thrustmaster. The biggest thing that I saw missing in that video is they really glossed over their whole design and engineering process. They really like to focus on their manufacturing and make you think that manufacturing is the critical element to achieving a good design. The manufacturing, the people out on the floor, are going to be responsible for execution of creating a very good component, but they have no idea what shape to make the propeller. That's where design and engineering comes in, and that's going to be a critical influence on the efficiency of your ship. Because if we're talking even 1 or 2% loss in efficiency, that translates into millions of dollars over the life of your ship. One element here that I would definitely ask Thrustmaster more about is their design and engineering process. What are they using for their propeller shapes? Are they using, say, standard propeller shapes that are existing that have been around for 100 years? Or have they taken those designs and then further optimized them with CFD? Or do they have their own proprietary propeller shapes? And where are those best suited? So that's one thing that's definitely worth looking into with Thrustmaster. You can first ask about the reliability, and that's an excellent question, but then you also need to ask about the efficiency and the performance of their designs. Are you going to get both reliable performance and a high efficiency design that's going to give you a little bit of an advantage in reducing your costs and giving you a little bit more profit than your competition? These are the critical questions when you're thinking about support from your vendors. So I hope you enjoyed that reaction video and it gave you a bit more insight into what I'm looking for when I evaluate vendors for ships. The next step is always to then take those generalized questions and apply them to the specific situation for my client. How exactly does this particular vendor benefit my particular client? And that's part of the value that I provide as the consulting engineer. So what do you guys think? Do you want to see more reaction videos like this? If you do, let me know in the comments down below. Even send me some links of other videos you would like me to review. Thanks very much. I am Nick, the Naval Architect. Thanks for watching. Some firms like to brag that they have built ships for over 100 years, that they have been building them since the 1800s. And my thought is always, well, that's good, but are you still using sails and rivets? Tradition is good, but we need modern science to balance it. And DMS brings big science to your ships. We apply advanced engineering from the larger ships to create high-performance solutions on your smaller vessels. So check out our website and learn how we can make your ship stand out. Thanks very much.